Hi, this is Adam Griffin with the first video for this week. So today is going to be problem number 1. And this deals with wave interference. So we're going to be using equations for fringes, so bright fringes and dark fringes. And yeah, so problem number 1 states an FM radio station with a frequency of 89.8 megahertz uses 2 antennae, A1 and A2, that are spaced 8 meters apart. The antennae are driven with the same signal phase, so they're always each time one is releasing a very high pressure wave, so it's a trough. The other one is also giving off a trough. So these two waves are symmetrical. For part A, we're asked what is the wavelength of the radio waves in the air. So this part is very simple, so all we have to do is use the relationship between wavelength, velocity, and frequency. And we know that 1 megahertz is equivalent to 1 times 10 to the 6th hertz. So we can plug that in. We use the speed of light for our velocity, so 3 times 10 to the 8th meters per second. And then we divide it by our frequency, which is 89.8 times 10 to the 6th hertz, and we get a wavelength of 3.34 meters. So for part B, we're asked to find all of the angles at which there are minima, and we're giving our answer in radians. So for the minima, we're going to use, and I accidentally switched up part B and C on this, but we can ignore that. For the equation for the dark fringes, which is the same as the minima, it is m plus 1/2 times the wavelength divided by the distance between the two antennae. So our distance between the two is 8 meters, as shown up here. And we can, this will be a constant because the wavelength and distance between the two do not change. And this is the same in both parts B and C. So we get a value of 0.4175. And then all we're doing is multiplying that by our m. So for part B, we just add 1/2 to find the dark fringes. So for 0, it's multiplying this constant up here by 0.5, and then 1.5, 2.5, etc. So that gives us our dark fringes, or our minima, at 0.209 radians, 0.626 radians, 1.044 radians, 1.461 radians, and so on. And also, because it's symmetrical, the other dark fringes in here are the negatives of these angles. So we also have a dark fringe at negative 0.209 radians, negative 0.626 radians, and all of those other ones. So that is where all of our minima are. So for maxima, which is what part C is asking, and this is part C, we aren't doing the m plus 1/2. Instead, we're just doing m, which represents where all of the bright fringes are. And this is from the textbook. So again, we have this, which is a constant, and we're just multiplying it by 0, 1, 2, 3, and it gives us these angles. So 0.4175 radians, 0.835 radians, 1.253 radians, and so on. And this one also, there are maxima at the negatives of these angles. So this is part C, and part B, and part A is right up here. So that is how you solve problem number 1. I hope that it was clear. Sorry for the mix-up on here. And yeah, that is all. So thank you for watching.